Today we're starting our graphing linear equations unit. It's a great unit, a great preview of what you're going to be doing for a lot of 8th grade next year. So definitely a unit where you want to try and ask as many questions as you can, but yet not feel overwhelmed if you don't feel like you have a super strong grasp right away, because you will review this again in 8th grade. Right now, our test for this unit is scheduled Friday, June 5th, but that's a ways off, so it's subject to change. For our do now today, I just want you to read page 3 in the booklet with the vocabulary and complete page 4. So take a second, pause the video, and do that. So here on our coordinate plane, we're familiar from when we did our ratios and proportions unit, but just a quick reminder, right? We've got our y-axis that is vertical, y to the sky, and our x-axis that is horizontal, that goes left to right. Our coordinate plane is broke up into 4 sections, 4 quadrants, starting with quadrant 1, then going counterclockwise to quadrant 2, 3, and 4. And we use Roman numerals to write that. On the edges of our axes, we always have arrows, and that center point right here where they meet is called the origin, the ordered pair 0, 0. Right? When we give the coordinates of a point or the ordered pair, we always write a parenthesis, our x coordinate, comma, our y coordinate. It is always x, then y. Okay? So let's find our coordinates. Let's see. A is going to be -1, 1. B, 4, 3. C, -2, -1. D is on the y-axis, so that is going to be 0 for our x and -1 for our y. G is 1, 4. K, 5, -1. T is on the x-axis, so -3, 0. And R, -2, -4, just like that. Okay. On number 2, we're going to plot the points ourselves. Again, you have to do this on your own and then just reference the video, but you can't really just follow from the video. So again, it's always x, then y. So G, -2, 2. So I go -2 on the x, 2 on the y. Boom, there we are, and we label with a capital G. H, 0, 3, 0 on the x, 3 on the y, H. And it's not connect the dots. We're just plotting points. P, 2, -2. M, -3, 0. And there we are. Now we're going to just say what's what in the quadrants. So in quadrant 2, our x is negative and y is positive because it's above that x-axis. Quadrant 3, our x is negative and our y is negative. It's below the x. On page 5, we're going to look at the difference between linear and nonlinear equations. Linear equations are what we'll study in 7th grade and what you'll spend a lot of time on in 8th grade as well. And linear means that when it's graphed, it produces a straight line, a line that we could draw with a ruler. And that's pretty easy to see visually on the graph. One of the things we want to notice is, how do we tell if we're just looking at the equation? And we use the equations y and x, right? Because it's on that coordinate plane. Well, I can tell if an equation is linear because all the variables have an exponent of 1, right? So they all have that little invisible exponent of 1, so I know they are linear. It doesn't matter if we have negative numbers, positive numbers, greater than 1, less than 1. It just matters about the exponents of the variables. We also have nonlinear equations in math where they have a curve, and we see those when a variable has an exponent that's other than 1. So it could be greater than 1, it could be, negatives, but it's not 1. The quadratic, or another word for that, is called the parabola. You'll spend some time studying that in 8th grade and more in high school. We get that nice U shape or upside down U shape, and it has an exponent of 2. Our cubic, which gives us a nice curve, you'll study more in high school. Right? And the cubic has an exponent, highest exponent of 3. And then our quartic, which winds up making almost like a U shape, and sometimes there's a little curve in there, has the highest exponent of 4. Okay, so down here, we're just going to identify and circle all the linear equations below. So pause the video, do it yourself, and then come back and check. Okay, so our linear equations, y equals 2x, y equals x, and that's a special one. That's what we call the parent function, and we'll talk more about that when we talk about something called slope. Y equals 6x plus 4, and that's it. Everything else has an exponent other than 1, so they are nonlinear. On page 6, we're going to graph our first linear equation. Kind of a big deal. We're going to use the table method. Later on in the unit, we'll learn a different method called slope-intercept form that I think you'll like later when we get there. But for now, table method, very effective. The first thing we're going to do is we're going to take our equation and we're going to write it in something called slope-intercept form. And those words will give more meaning as we go through the unit. For right now, it's just important that you know that means we're going to isolate the y. Get it by itself. And this is slope-intercept form. So we just want to make sure we have the y value, our equal sign, then our x term, and then our number. I wanted to say integer, but it doesn't necessarily have to be an integer. Okay. When we do the table method, we're going to choose our x values, and we want to get a nice picture. So we're going to choose 2 negative values, a 0 value, and 2 positive values. So a little note I want to write in here. So if we have a fractional coefficient of x, so if that piece right there is a fraction, then we are going to choose x values that are a multiple of the denominator. And that'll make our life easier when we go into step 3 and substitute into the equation to find the value of y. And we'll see an example where we need to do that. Then we'll plot each point. And we're not going to label the point today. And then we're going to connect the points to create a line and label it with the equation of the line. Okay? So our first example, 2y equals 6x minus 4. We've got our y, our equal sign, our x term, and our number. The only problem is the y isn't isolated because of that 2 there. So we need to eliminate it. To eliminate it, we're going to divide everything by 2. So each piece here gets divided by 2. So the whole left side. I'm sorry, whole right side. So we get y equals, now we do each piece. 6x divided by 2 is 3x. Negative 4 divided by 2 is negative 2. And we're going to write that equation right here, where we have the y equals 3x minus 2. Or we could have just written the 3x minus 2. Okay. Here we have an integer coefficient. Okay. So when we have an integer coefficient, we're always going to choose these 5 x values. We're always going to choose negative 2, negative 1, 0, 1, and 2. Okay. So now we'll just go to our equation. We're going to substitute in for x and simplify to find what y is. So 3 times negative 2 minus 2. And if you don't have enough space, you want to use a piece of scrap paper. So 3 minus 2 is negative 6. Negative 6 minus 2 is negative 8. So our y is negative 8, which makes our first point to plot negative 2, negative 8. And we keep going. Substitute in now negative 1. 3 times negative 1 is negative 3. Negative 3 minus 2 equals negative 5. So that's going to be negative 1, negative 5. Now substitute in 0, my favorite one. 3 times 0 is 0. 0 minus 2 is -2. Now at this point, because our x values have a consistent pattern, we should be seeing a consistent pattern in our y's. So I can see going from one point to the other, while we're adding 1 in our x's, we're adding 3 in our y's. And that should hopefully keep going as we go through our table. And we're going to show all our steps. So we got 3 minus 2 is 1. Yup, it's still holding. Good. And our last one, 3 times 2 minus 2, that's 6 minus 2, which is 4. So that'll be 2, 4. And notice I'm writing at each step in that nice ordered pair. Now we can go to our coordinate plane and start graphing. So -2, -8. And if you are graphing by hand, you're doing it on a piece of paper, you should really be using a pencil. This way you can go back and you can make corrections and then go over it in a marker so you can submit a clear picture on Google Classroom. I'm doing it in pen so you can see. So I've got my ordered pairs there plotted. I want to make sure it looks like they'll form a straight line. It does, so that means I did my work correctly because this is a linear equation. It should make a straight line. Now I'm going to create a line, and I'm going to extend that line through the coordinate plane. And that's an important habit we're going to build for later on, through the coordinate plane. My lines get an arrow on each end to show it continues on forever, and then we're going to label it with our equation. Y equals 3x minus 2. So our second example here is a little more complicated to get it into that slope-intercept form where we're isolating y. And again, if you want more room, use a separate sheet of paper. My first step here to get to isolate y is to distribute. So we're going to get 8 minus 4y equals -2x. Now I'm getting the y by itself, so I'm going to subtract 8 from both sides. So we get -4y is equal to -2x minus 8. And then we'll divide both sides by -4. So I'm just going to swoop my work up there. On the left side, we have y. -2 divided by -4. We reduce that. That's a positive 1/2. So we've got a 1/2 x. And then -8 divided by -4, positive 2. So there's our equation. Y equals 1/2 x plus 2. And we write that 1/2 right in line with the x. Now here's where we have that example where we have that fractional coefficient. Okay, so when we have that fractional coefficient, we're going to choose x values that are multiples of the denominator, so multiples of 2. Because it's 1/2. If it was 1/3, we talk about multiples of 3. We're still always going to use 0 as one of our x values. So then our positive multiples of 2, I would use 2 and 4. Okay? And then our negative multiples of 2, -2 and -4. Yes, you could use 6 and 8 and 10, but at a certain point, we're going to fall off the coordinate plane. So keeping it closer to 0 like that, where we get that nice consistent pattern, is great. Now we're just going to substitute in. So 1/2 times -4 plus 2. 1/2 times -4 is -2. See, we're getting an integer there because we made it a multiple of the denominator. That's why we're doing that. -2 plus 2 equals 0. If we didn't, we wouldn't have a way to graph it, right? We can't graph fractions on the coordinate plane right now. So we get -4 comma 0. 1/2 times -2 plus 2, so that's going to be -1 plus 2, so that'll be 1. So right now I'm seeing a pattern. As our x's go up by 2, our y's are going up by 1. Let's see if that holds. 1/2 times 0 plus 2. So we get 2. Yep, still holds. 1/2 times 2 plus 2. We get 1 plus 2, which is 3. Some of you might be asking, can I just follow the pattern? No, not yet. We'll get there. Practicing with the table method. 1/2 times 4 is 2. 2 plus 2 is 4. So we get 4 4. So using those multiples of the denominator of our fractional coefficient worked really well. So now we'll go and graph -4, 0, -2, 1, 0, 2, 2, 3, and 4, 4. Again, I want to check, does it look like a straight line? Because it should be. Yes. Now I can connect the points with a straight edge, extend through the coordinate plane, and label with our equation. So if you're submitting your work through Google Classroom, after you're done using your pencil, go over it with a marker. Okay? So on your classwork today, you're going to complete pages 7 and 8, where we're doing some work with linear versus nonlinear, graphing using the table method, and some general just kind of coordinate questions. So as you're going through and you're graphing, right, we have to make sure everything gets put into slope-intercept form. If there's a fractional coefficient, you're using that as a multiple of the denominator for your x values, and some you might want a little more space to practice putting your work into slope-intercept form. Okay, and we're going to do one more example. I'd like to do one more example of taking an equation and putting it into slope-intercept form. So first thing we have to do is get rid of those parentheses. So we distribute 4y plus 2x minus 16 equals 16. Now we want to isolate the y. I want to get it by itself. So I'm going to start moving my terms over. So I'm going to subtract 2x from both sides. Okay. So we get 4y minus 16 equals, and on the right side, 16 minus 2x, those aren't like terms. We can't combine them. So instead, I'm just going to rewrite that problem. I'm going to write my x term first, negative 2x, and then that positive 16. Okay. We'll add 16 to both sides, so we're isolating our y term further. Okay. Add 16, line it up under its like term, and we get negative 2x plus 32. Last thing to do, divide both sides by 4. So we get y equals negative 2x divided by 4 is going to be negative 1/2 x. 32 divided by 4, a positive 8. So we get y equals negative 1/2 x plus 8. Today's math jokes for Matthew Folks was submitted by our very own Harrison Galinas. It's a good one. Parallel lines have so much in common, it's a shame they'll never meet. And we're actually going to learn some parallel lines in this unit. So great joke. Thank you, Harrison. Have a great day, everyone.